Hello students, welcome to my channel Engineers Academy. Do subscribe my channel in order to reach much more audience like you, and that will help me to grow my channel as well. Now we are going to solve these two problems which says that in order to move a rack truck, two cables are attached at A and pulled by wrenches B and C as shown. Knowing that the tension in cable AB is 2 kips, determine the components of this tension in cable AB at A by the cable, right? So we have to find the components of the tension in this AB cable. And similarly, in the second problem, we are given the magnitude of the tension in AC cable, and we are asked to find the components of that tension in AC cable as well. So now I have redrawn this diagram. This is a free body diagram, right? And we are considering the positive x-axis like this. We are considering the y-axis like this, and this is our positive z-axis. And this is that point A where the truck is located. And we are given that this distance, since the truck is on the inclined surface, right? This surface is making 30 degrees with the horizontal. So we can say that if this is my x-axis and this x-axis is parallel to this surface, so this means that the inclined surface, this surface is making 30 degrees with the x-axis. So the distance between this edge and the location of the truck is 54 feet. This is given that this is 54 feet. So this direct distance is 54 feet. Now, if we look into this diagram from the side, from this side, so this is our side view, and we can see that this is my point A, and this is the x-axis, and the y-axis is perpendicular, and the z-axis is out of the screen. And somewhere here is our point B, and this blue line represents that cable AB. So we need to find, is we know that the tension in AB can be represented as the magnitude of the tension in AB. This is the magnitude times the unit vector from A to B. The unit vector from A to B. And similarly, we know that the unit vector from A to B is the position vector from A to B divided by the magnitude of the position vector. Now we know that the position vector is, we can write that the position vector is, let me write it here, that the position vector is dxi plus dyj plus dzk. Now what is dx, dy and dz? So dx, dy and dz, these are the distance between point A and B along the x-axis. Dx is the distance between point A and B along the x-axis. Dy is the distance or the separation between point A and B along the y-axis. And dz is the distance or separation between point A and B along the z-axis. And now we are finding the unit vector from A to B, since in the problem statement we are required to determine the components of the force exerted at A. So this cable, if this cable is exerting the force at point A, and if we cut this, and then the tension must be acting from A to B. So the tension is acting from A to B, which is represented by this brown arrow. So the unit vector, the position vector will be from A to B. Now the distance between, the separation between point A and B along the x-axis, that is dx, this is that dx. And we are given that this distance is 54 feet. In the problem statement, in the diagram, this is 54 feet. So we can write that this is 54. This is 54, this is 30 degree. So now this dx will be 54 cos of 30. So 54 cos of 30 is 46.765 feet. And now as we have defined that the positive x-axis is towards the right, and the point B, the separation between point A and B is dx, which is 46.765 feet. But in order to reach that point B from A, since the tension is from A to B, so in order to reach this point B from point A, we need to travel the dx distance in the negative x direction. So this means that dx is the position vector AB, dx is minus 46.765 I. So this dx, dy, and dz, these are the components of the position vector from A to B. So this means that the magnitude, the separation between point A and B is 46.765, but we need to travel in the negative x. So that is why we need to write minus sign here. Similarly, the separation between point A and B along the y-axis is this distance, or we can say this distance. So this distance is dy, and we can find this dy, this small distance, this distance is given directly. This distance is 18 feet, but this distance is 27 feet. This is 54 sine of 30. This is a right angle triangle. This is 54 feet. This is 30 degrees. So this is 54 sine of 30. So this height is 27 feet. Let me represent it here. This height is 27 feet, and this is 18 feet. Now the separation between point A and B along the y-axis is this dy. And in order to reach that point B from A, we need to travel the distance in the positive y direction. Or we can say that in order to reach that point B, first we need to travel in the negative x, and then we need to travel in the positive y, like this. So we can say that this is plus dy is 27 feet. This is 54 sine of 30, and plus this 27 feet plus 18 feet. So we will write that this is 27 plus 18, and this is in the j direction, plus dz. Now dz, in the side view, we cannot see the dz, the distance between point A and B along the z-axis, since the z-axis is out of the screen and that dimension is not visible in the side view. So for that we have to look for dz. So this distance, this is dz, the separation between point A and B along the z-axis. So if we look into this diagram from this side, this is dz, right? So dz is given directly, that is 36 feet, right? So we can write that this is 36 k. So now I can explain it in this 3D diagram. In the position vector tells us the position of point B relative to A. That is why this is the position vector from A to B. So uh, in order to reach that point B from A, we need to travel this distance. This distance is 46.765 feet. So first we need to travel this distance in the negative x. So that is why we have 46.765 in the negative I. So first we will travel that distance dx. Then we need to travel this distance that is parallel to the y-axis in the positive j. And then we need to travel this distance in the positive z. So this is minus, this is plus, and this is plus. So now we can write that the position vector from A to B, position vector from A to B is minus 46.765 I plus 27 plus 18, 45J, and plus 36K. And now we can find the magnitude of the position vector from A to B. The magnitude will be, we need to take the squares of all the components by using the Pythagoras theorem and taking the sum. So 46.765 square plus 45 square plus 36 square under the square root. 46.765 square plus 45 square plus 36 square. So this is 74.2 216 feet. The units will be in feet since dx, dy, and dz is also in feet. So we can say that the units of this is in feet, and similarly this is in feet as well. So the magnitude of the position vector is 74.216, or we can say that the length of the rope from A to B is this 74.216 feet. Now this is the unit vector, right? So we can find, we are given the magnitude of TAB, which is 2 kips. So 2 multiplied by the unit vector, we can say the TAB vector is 2 kips multiplied by the position vector. So the position vector is minus 46.765 I plus 45J plus 36K, and the magnitude is 74.216. So now we can write that we need to divide each of these components by this magnitude. So this divided by this, then 45 divided by this, and 36 divided by this, and multiplying all these by 2. So that will give us the x, y, and z components of the tension from A to B. So now we can write that this will be 2 into minus 46.765 divided by 74.216 I plus 2 into 45 divided by 74.216 J plus 2 into 36 divided by 74.216 K. Now let's find all these components. This is 2 multiplied by minus, let's say 46.765 divided by 74.216. So the magnitude of the x component is 1.260, and the negative sign will remain there. Similarly, plus, now this is 2 multiplied by 45 divided by that magnitude. So this is 1.213 J, and multiply by 36. This is 0.970 K, and the units will be kips. Since this is in since the unit vector is in feet and this is in feet, sorry, the position vector is in feet and this magnitude is in feet, so feet will cancel out with feet and we will be left with 2 kips, right? Since the unit of this 2 is kips, so we will be left with this kips units. Now in the problem statement, we are asked to determine the components of the force exerted at A by the cable. So these are the components. This is TABX, this is TABY, and this is TABZ in kips. So this is the solution of this particular problem. Now in the second problem, we need to find the components of this TAC, which is acting from A to C. Now again, everything will remain the same, right? The diagram will remain the same, just we are going to consider TAC. So from the side view, everything will remain the same. This point will become C, right? And let me erase all this, and the height of this will become a bit longer, right? Since the point C is 28.8 feet, so this is 18 feet, so we need to make it a bit high, this point. So this is now that point C, which is that point C. And now from A to C. So now this is very simple. We can again apply that TAC. Now we can say that TAC is TAC magnitude times the unit vector from A to C now. and we need to find the position vector from A to C and its magnitude. Now again, the separation between point A and C and the x. So again, we need to consider this. So in the x, everything will remain the same. This is dx, right? So the separation between point A and C along the x remains the same, since this point B and point C, they are in one plane. They are at the same distance, right, from point A in the horizontal direction. So we can say that AC, so dx is that 46.765 I, and that is in the negative. We need to travel that distance since that point C is away from point A in the negative I direction. This is our positive x. So point C is on this side, on the left side. So we need to travel this distance in the negative x. Similarly, the separation between point A and C in the y is again the same, this dy. So this distance is 27 feet. This triangle remains the same. So this is 27 feet. And now point C is 28.8 feet. So now this distance is 28.8 feet, right? So dy will be, we can say that dy will be plus 27 plus 28.8. And this is in the positive j, right? The separation between point A and C. In order to reach that point C along the y-axis, we need to travel the distance in the positive y direction. So this must be positive. And similarly, the distance between point A and C in the z direction. So this is the distance between point A and C, and that distance is given, that is 45 feet. And this means that in order to reach that point C from A, or we can say that point C is located with respect to point A in the negative z direction. So we need to travel 45 feet distance in the negative z. So we can write that this will be minus, this is minus 45k, right? So we will write that minus 45k. So now this is the position vector from A to C. We can simplify it. This will be 27 plus 28.8. So this is 55. So this is 55.8. Now we can say that the TAC, the tension from A to C vector is magnitude. So the magnitude is given in the problem statement, that is 1.5 kips. So 1.5 into the position vector from A to C. So the position vector from A to C will be minus 46.765 I plus 55.8 J minus 45k. And let's find the magnitude. The magnitude of the position vector from A to C will be, so we need to take the squares of the square root of the sum of the squares of all the components. So that is 46.765 square plus 55.8 square plus 45 square. So this gives me 85.589, or we can say 590 feet. So the magnitude is 85.590 feet. Now this will be 1.5 multiplied by this fraction I plus 55.8 divided by 85.590 J minus 1.5 into 45 divided by 85.590 K. So now let's find all these. 1.5 multiplied by 46.765 divided by 85.590, 85.590. So this gives me 0.819. So minus sign will remain there. 0.819i plus 55.8. So this is 0.978j 45. So this is minus 0.789k, and the units will be in kips. So the tension from A to C. So these are the components of the tension in AC rope. This is the X component, this is the Y, and this is the Z component. So this is the solution of this particular problem. I hope it will help you in your learning. Do consider subscribing my channel so that we should reach many more students like you guys, and that will help me to grow my channel as well.